Hello, my name is Matt. I am the Community and Education Lead for Digital, and welcome to this introductory video to the Year 6 unit of work in our Coding for Climate Action series of units of work. If you're not aware of what Coding for Climate Action is, it is a series of schemes of work or units that can be implemented by you for free in schools aimed at Key Stage 2 and Key Stage 3. And broadly, the units of work try to show students the relationship between the national curriculum for, in particular the programming elements of the national curriculum for computing, linked up with physical computing, in particular microbits, and wrapping that in the context of climate action, how we can use this kind of suite of learning to understand that actually what we learn in computing can be related to the real world in such a way that we can think about having a positive impact as well as our future selves and what technology and computational thinking might mean for us as we grow or as the students grow older. So hopefully that sounds interesting and exciting. So if you are interested in getting to know more about this, then you'll want to come to the website to actually get hold of the resources. So you've probably found your way to the website already because you're here watching this video. But in case you haven't, to get to our website, just go to digital.charity and then you can click on resources and choose Coding for Climate Action there. And that will bring you to this page. Now, if you scroll down, there's of course more details on the webpage about the ethos of the units of work and some of the other support materials we have. But the main thing to focus on right now is the links to the actual resources themselves. So we can see here we've got different contexts for each of the units of work. So Year 4 looks at data logging using microbits and thinking about climate action. Year 5 is about climate awareness and thinking about what the causes of the climate crisis and emergency are and how we can develop things called early warning systems to help mitigate those. Year 6 is what we're looking at, again, using the microbit to detect and respond to aspects of the climate crisis. And it follows on very nicely from the Year 5 unit of work, but you can do them as standalone units as well. But with a focus on careers, how we can actually relate this to a real world of careers as well that are out there for young people to hopefully aspire to. And Year 7 is again looking at what the causes of the climate crisis are and some different contexts in which we can think about developing early warning systems to help mitigate the impacts of the climate crisis. Okay, so let's actually have a look at the Year 6 unit of work. So if you click on the link, it will take you through to a Google Drive, completely free for you to use. You will need to download these materials and use them yourself. I mean, you can use the PowerPoints from our Google Drive repository, that's fine. But if you want to make any amendments or adjustments or anything like that, you're going to have to make your own copies of the materials, which you are more than free to do. So let's have a quick run through what we've got in front of us. I won't talk about everything and I won't go into minutiae about any of this, but let's just think about what is actually on offer for you here. So of course, we've got the lessons. So there are 6 lessons, but the final lesson is merged over one PowerPoint covering 2 lessons, or one kind of set of materials covering 2 lessons. So we'll get into lesson 1 today in a minute. But just so you are aware, there are other materials that you'll need as the lessons continue. So in case it's of interest, we have got additional guidance here, which helps us understand, one, how to use the microbit in a bit more detail. You might be new to the microbit, a bit nervous about using it. That's partly why we're doing these videos, but we've tried to provide as much documentation as we possibly can as well. Some ideas about if we just scroll down, sort of how to, pedagogical ideas about how we can try and elicit engagement from students and things like that. You will know this stuff better than us, but we don't, your learners better than we do, of course, but we don't want to not include these things in case of use. And of course, climate context is a really emotionally powerful topic to be looking at, right? So we don't want to be developing or causing any anxiety or worries around this at all. So we're hoping these units of work are a method of inspiring people to take action and be part of a solution rather than feeling climate anxiety or helplessness. But if those things do arise, of course, hopefully there are some support materials here as well, which might be able to be of use. So there we go, that's there. Use it if necessary. We've got an overview of the scheme of work as well. So we've got the lesson objectives mapped to the national curriculum. So again, if you want to be thinking about the kind of the broad overview of the unit of work, please take time to look at that. But of course, we'll be going into each of the lessons individually as the videos go on, so I won't linger on that. But that is there for you, should you so wish. Now, the main kind of thing for students to be aware of as or you to be aware of on the students' behalf as we're progressing through the work is there is a work journal for students to be completing as lessons go along. So this is something that would need to be, if I just open that up, would need to be distributed to students so they have their own copy. Okay, you'll see it can't be edited by them if they don't have access to it. So it's important they have access to their own copy that they can edit. And there's, name, date, all that sort of stuff. And then links to different tasks for each lesson at the top, or maybe you can just jump down. I don't know why it's not working, but there we go. Things never work when you want them to. And so we can see there's different links and different tasks and activities there for students to be engaging with. And at the end of each lesson, there is a career skills level up, a reflection on what skills have been used in that lesson that kind of is demonstrated in a radar chart. So that is something that also needs to be distributed to students. So they have hopefully their own copy, and you can see that is a spreadsheet here. So students can open that up, and we'll see at the end of each lesson, a student would say, okay, well, they can give themselves up to 4 points for the lesson. Okay, no more than 4, no less than 4. They need to distribute the 4 points, like a bit like leveling up when, I don't know, Pokemon things level up, don't they? And stuff like that when they, evolve. So let's say at the end of lesson 1, students say, well, I've done loads of programming, so I'll give myself a 2 for that. I don't think I've done any engineering, but I did solve some problems because I got stuck and I had to speak to a friend or a teacher, and I also did some tea work. So we can see, okay, when we put those numbers in, our total goes to 4, which is green, fantastic. And we can see how our radar chart gets bigger as a result of that being inputted. And over time, let's just put some numbers in. You can see how skills develop over each of the lessons. So after each lesson, complete this, and it can either be left like that or take a screenshot or copy and paste this actual chart and pop it into overwrite this image here. Okay, hopefully that makes sense. We'll have another look at that in due course. Right, so let's get into lesson 1. Oh, before we do that, these are all in the Google environment, so Google Sheets, Google Docs, and things like that. If you are a Microsoft school, we've got a zipped up Microsoft package all there, which is, things work a little bit differently, but it's all in the lesson plans. If there's any kind of differences, how some of the technology works, for example, updating the chart that we just looked at. So if Microsoft Office is a better for your where you are, then please use that. Right, lesson 1. So the overview of the scheme of work is to kind of show students one aspect of the national curriculum, i.e. programming fundamentals like using variables, iteration, selection, things like that. So meeting the national curriculum for the programming strand, but also looking at the variety of tools and sensors and components that microbits have and how we can think about using those with increased confidence. Now, a lot of those components and things are looked at in year 5. So we're looking at consolidating it in year 6. But if you haven't done the year 5 unit of work, that's perfectly fine. Everything is stepped through and explained. So there's no problem if you haven't done the year 5 unit of work. And you could do year 5 and year 6 unit work in the same year, right? You could do them both in year 6, for example, or you could do them both in year 5. But we've just opted to say there's one per year. But you guys know how you want to do things best for your places. So do it as you wish. So for each lesson, we can see there's the PowerPoint and a teaching guide, and there's any other materials that you'd need for that lesson. They can also be found there as well. I won't go through the teaching guide line by line, but I will just show some of the key points in here and then get on with the lesson. So each teacher guide will have, of course, like a big question helping us understand like the overall context of that lesson. So in this case, it's thinking about how technology and careers, an idea about having a career in technology can help tackle the climate crisis. And then we're looking at as well understanding some of those key programming concepts, which I've already discussed, and then understanding that they can be implemented to make physical computing systems. We'll have a lesson snapshot at the start of each learning guide as well, so you kind of get a feel for what has been covered, links to the national curriculum, any computational thinking kind of links as well, any materials that are needed from students or teachers, all here. So links to any microbit code, for example, any news articles, things like that, any lesson preparation that you might need, getting your microbits ready, so on and so forth, handing out the journals, and then of course all of the actual kind of narration, I suppose, of the lesson, and including like answers and details and kind of extra kind of information as the lesson goes on. Hopefully that's all straightforward. So let's actually have a look at the lesson. Now, this is the first lesson in the unit of work. Obviously, you know that. And so for that, we'd really be grateful is if this slide is in the PowerPoint, it would be really great if you could take the time to complete the survey, the pre kind of unit of work survey, and the students could complete the pre-unit of work survey as well. This is free materials. We're really lucky that Amazon Future Engineer have helped us develop these materials, and we're really grateful for that. But of course, in order to keep developing things and keep offering them for free, it's really powerful if we can get feedback about the impact of what we offer and what we have. So I know time is so precious, but in order for us to do this and keep doing this, just taking those few minutes to complete the survey before the unit of work and another survey at the end of the unit of work makes all the difference to what we're trying to do. So thank you in advance if that's something you're able to do. We really, really, really appreciate it. Cool. Sales pitch on the survey done. Right, so the lesson actually starts by just starting to think about the climate crisis and the kind of state of the world and how there is a relationship between technology and what the world looks like, sometimes for better, sometimes for worse. So just trying to draw out ideas around what the relationship between these two images are, and then firming up a little bit more what climate change is and what the causes of climate change are. Now, if the students have done the Year 5 unit of work, they would have seen this video already, so there might be no need to show it again or go over it in too much detail. But of course, this video here, which you can just click on to play or to link to, or it's all in the lesson materials, might be something you do want to show even if the students have done the prior unit of work. So having thought about climate change, what it is, of course, we want to kind of relate climate change to our local areas. So there's another activity here from the BBC, which, if I just open it up, allows you to, oops, if I can copy and paste properly, allows you to there we go. Allows you to look at what climate change will be like in your actual area. So you type in your postcode and it will give you some information about what the changes might be to certain weather events. So we can really start to think about what the impacts will be. It's really important to think not just about climate change as a global thing, but what it might mean locally as well, because it's going to be very different even for different parts of the UK. So having thought about that, we want to think about what jobs people do to help fight climate change, because we're trying to drive towards an idea of how there are careers that people can have, that people do have, which are designed to try and have a positive impact on the world, in particular, mitigate or adapt to the climate crisis. So we want to draw that out and set up that whole kind of through line for this unit of work, that relating what we're learning to an actual event in the world and the fact that these young people in front of us can aspire to be part of the solution, and there is a career, a life choice around that, is a really powerful thing we're trying to hopefully get across. Introduce students to their climate career work journal as well as the career skills charts, and help students understand that they're going to be completing activities as the lesson goes on. So we can see up here a note to complete lesson 1, task 1. So anytime you see a note somewhere in the PowerPoint, that's a note to jump over to the career skills, the work journal. There we go, to answer these questions here and get some feedback. There we go. So the next few slides kind of go through the changes in technology, and this is all mapped out really in detailed in the lesson plan, so I won't narrate it too much. But the fact that hazards have been increasing over the last 50 years as a result of climate change, but deaths have been decreasing, and that's because we've been able to utilize technology to help detect and mitigate those sorts of events and stop them from being as hazardous as they could have been otherwise, which is really cool stuff, and that's what we want to try and drive people towards. So with that in mind, the thought of like technology being part of the solution, we realized that in order to develop technology that can help adapt to and mitigate the climate crisis, they need to have sensors, i.e. like the microbit has sensors. So bringing to life the fact there are things with sensors all around them, all around us, that we use day to day already. We can see here a little note to jump over to the second task as well. So having kind of got our heads around what sensors are and the fact that they are in the world around us, then we can introduce the microbit, hooray, and realize that, yeah, these also have sensors. So we can start to see the relationship between real world kind of physical computing and our core microbit devices, which we can use to create similar versions of existing technology. And that brings in our first program, so a warning system program. And I'll just jump over to the actual code. You will notice while that's opening up, all of our code is pre-written with some additional like activities for students to do. So there's no kind of blank thinking, blank template. Students have to go to the MakeCode environment. All the code is partly pre-written, so they can just jump straight in and have something working immediately that they can build upon, make predictions around, modify, explore the kind of behaviors of. Okay, so we want students to be making a prediction about what this code will be doing. If I jump over to this, there we go. So this is the pre-written code for students to look at. Now we can see here that when this program starts, we have a danger variable set to 0. So a variable is when a program holds on to, stores, not holds on to, I suppose, stores a piece of data, in this case a number, 0, and gives it a name. So when we use that name, we actually reuse the number. Okay, and we can change that data that's being stored. We can increase it, decrease it, completely overwrite it. And we can make decisions based on that number as well. So when the program starts, we have a variable called danger that is set to 0, and we also show a heart icon. When the microbit tilts left, we'll set the danger variable to 1, or if the microbit tilts right, we'll set the danger to 1. Okay, so we can change it from 0 to 1 just by tilting the microbit to a left or right. And then while that is happening, or not happening, if the microbit's not tilting left or right, we have a forever loop. So that is a loop that's going round and round and round. So whatever is inside that forever, that blue forever block, will happen over and over and over and over and over again. And we can see we've got what is called a selection statement, an if statement here, and that is constantly checking, does the danger variable equal the number 1? So when we start the program, danger variable has got 0, so it does not equal number 1, okay? And so because that it would not be true, none of this stuff would happen. So we show the heart icon. However, if the microbit tilts to the left or the right, it sets the variable danger to 1, which means this statement is now true. Danger does equal 1. And because that is true, it will trigger all of these blocks of code inside that if statement block there. Okay. And these bits of code have a repeat 4 times. We'll show the X icon and play a warning sound. That will happen 4 times. And then when that's done, we set the danger variable back to 0. So it won't happen anymore. Okay, this kind of warning sound won't happen. Now, this is kind of the core skeleton code that we're going to be using for a lot of the unit of work. The idea that we can use a danger variable, toggling it from 1 to 0 to set an alarm off dependent on the environment around us. It's like the core learning or the core programming kind of technique that we'll be using. One, to help try and develop familiarity with how this is working. Two, because this code here is using so many programming fundamentals, it's really good for the students to get to grips with variables, selection, repetition, as well as some of the inputs, like in this case, the tilt left and right from the microbit. So yeah, we talk through this program with students. We think about what it might do when it runs, and we think what it could be used for, how it could be used to save lives. We're then going to get the students to actually download the microbit, and there's a guide, download the program to the microbit. There's a guide here on slide 13 and 14 to help you with that, but I'll just step through it anyway. So in order to do it, we need to go to this slide. Shoots will be there already, but then we need to click edit code because I can't actually do anything with this code here. I can move it around, but I can't do anything. So I click edit code. It will take me through to the area where I can use the sort of access the code, and then I need to click on download. Now my microbit is already paired with this web page, but if it's not already, your microbits won't be already paired, so we can click on the three dots and there'll be here a button that says connect. And if you click on that, they will take you through a series of steps that connects and pairs your microbit. And once that's done, all I need to do is click on download and it will automatically put it onto my microbit. If you need more guidance on that, it's in the PowerPoint, and it's in the sort of additional documentation as well. Okay, so that's downloading, and that's just to demonstrate that for you. Once students have downloaded it, they can check that it works. We've got an explanation here, which I've already been through, but that's there for you to speak to the children or the students about. And then we've thought about what this could be for. Well, our suggestion is it's a skyscraper warning system. There's some details here about the kind of potential impact on skyscrapers of climate change. Okay, it's on my microbit, fantastic. But the students might have thought of something better or different. So, I'm really excited to hear about what they might have come up with. Okay, let's tilt mine to the left. There we go, tilted to the left. And we've got our warning, run away, get out of the skyscraper. Things are, we're outside of tolerance. I don't know why I'm excited by a skyscraper, potentially plummeting, but there we go. Cool. So that's the kind of the overview of the lesson. We've looked at all of those kind of different kind of elements of the microbit, some of its components, the kind of introducing some of the kind of some of the aspects of sort of core programming fundamentals. So the final activity for students is to then update their career skills chart, which is of course over here. So like I said, I did programming, I did some problem solving, and I did some teamwork. Okay, and then we can take a screenshot of that if they wish and pop it into their work journal just here and get rid of that image there, and off they go. Hopefully that makes sense. Thanks so much for kind of bearing with me through this tutorial. Hopefully it's explained the idea of the unit of work we're looking at and how best to get through the code and utilize it. Thanks very much, and fingers crossed, I'll see you for video 2.